right, ladies and gentlemen, we're going to go back a little bit in the chapter to lesson 9.3 and take a look at surface area again, this time of pyramids and cones. So our goal is to find the surface areas of pyramids and cones. Now these are the two solids that only have one base. So we'll find that when we look at the definition of each of these. So when we look at the definition of pyramid, it's a polyhedron, because each base is a polygon, but it has one base, and then the lateral faces are all triangles that share a common vertex. So that was that point that we talked about at the top. The height of the pyramid is the distance between the vertex and the base. This is going to be found inside. So you're going to find H inside the pyramid. The slant height of the pyramid is the height of the lateral face triangles. So the letter L, and that's an italics L, is used. So you'll see it kind of with this cursive italics L. But the slant height is as on the outside. We think of this as being on the outside, with the dealing with the lateral faces. A cone is a solid with a circular base and a vertex not on the base. So that's where we have the point across from the circle. The height of a cone is the distance between the vertex and the base of the cone. So if we notice, it's very similar to the height of a pyramid. And so once again, this is going to be found inside the cone. And then the slant height of the cone is the distance between the vertex and a point on the edge of the base. So this is on the outside. And we'll still use this cursive L to represent it. So let's take a look. We need to find slant height. So if you look here, this is what the height is. This is what we mean by inside. So this is H. These are the dimensions of your base. So it's a square pyramid. And so they want us to find the slant height. They're looking for us to find this height here, this outside. Green is going inside from top to bottom. Slant height is the outside of that triangle. So to do that, we need to use the right triangle formed by the height and then half the base. So we have a right angle here. So we know that the slant height squared, so this is similar to C squared, is equal to A squared plus B squared. This is the Pythagorean theorem that we're using here. And we just used that recently for one of our problems. All right, so we're going to plug in what we know. The slant height is our unknown, so that's going to stay C squared. The height was that 100 feet squared, and half of the side, so we're only going from the middle out to the edge, is 100 squared. I guess I'll keep this red because I labeled the slant height. And that's our L. We're finding L for the slant height. So we're going to have L squared equals 100 squared plus 100 squared is 20,000. Okay, you can type this all into your calculator. You then need to remember to take the square root. And you can use your calculator. So you're going to take the square root of 20,000. And we're going to round that to the nearest hundredth, so 141.42. So about 141.42 feet. So what that means is we stopped this problem at finding the slant height. In some of our problems tonight, we may need to find slant height and then go and find surface area. All right, so let's take a look at what the formula is for surface area of a pyramid. The surface area of the pyramid is the sum of the area of a base. All right, so not much different than the prism, except there's just one base instead of two. And 1/2 the product of the perimeter of the base. So we've got the perimeter again, and the slant height. So we're going to say S is equal to big B. This is area of base. So we have to remember our formulas for rectangles and triangles. Plus 1/2 P times L. So P is still standing for perimeter. So we're bringing quite a bit with us from our prism and cylinder formulas. We're just adding in the fact that we only have one base, so I only have one base, and now we've got this slant height that we've introduced. So let's find the surface area of a pyramid. All right, if we take a look here, we need to find L. I don't know what this slant height is, so it's going to be one of our steps. So let's take a look at what they say to do. Your formula is B plus 1/2 P times slant height. So what they're going to take us through is finding the area of that base. The base is a square. It's 6 by 6. All right? So we're going to do 6 squared, which is 36 feet squared. The perimeter of the base is all 4 of those 6's added together. So they do 4 times 6, which is 24. So we found B, big B. We found P. Now we need to find L. So we're going to have to use the Pythagorean theorem. All right. So L squared, slant height squared, is equal to the height, which is 4. If we look here, we have a height of 4, plus 1/2 this distance, so 1/2 of the 6. So we're substituting 4 in for h and 6 in for the side. So we have 4 squared plus 3 squared. And we do that, we get 25. We're going to take the square root. So we take the square root of 25, which is 5. So now we have what the slant height equals, we have what big B equals, and we have what perimeter equals. So we're going to use our formula now. The area of the base was 36. We have to use that 1/2, and we have the perimeter, which was 24, because 6 plus 6 plus 6 plus 6. And the slant height was 5. We're going to multiply all of those together, and we get 96. So the surface area of the pyramid is 96 because its area, it's square feet, or feet squared. All right, so you're going to need to go through and do your checkpoints. So let's take a look at number 1 together. Remember, my surface area is the base plus 1/2 perimeter of the base times the slant height. I like this one a lot because they give me the slant height. So I have to find the area of my base. I need to find big B, which is going to be 7 times 7. Just like in the last lessons, I want you guys to show me the work you're doing. So 7 times 7 is 49. We're going to have 1/2 the perimeter, and I need to add those up. So 7 plus 7 plus 7 plus 7 is 28. So 1/2 times 28 times that slant height of 9. So when we take that 1/2 times the slant height times 9, I'm going to need to get my calculator. So I'm going to do 1/2 times 28 times 9 is 126. And so when we add those two together, we get 175 inches squared. You guys are going to do number 2 on your own. And we will check in class. But I want to go through number 3 with you and talk you through that before you do that one. Notice we have the height here. We don't have the slant height. So you're going to have to find this slant height. So you have to find this L. Keep in mind that this distance here is 5. And so what you're going to have to do first is you're going to have to do Pythagorean theorem. And get what slant height equals. And then you're going to have to do the surface area equals to area of the base plus 1/2 perimeter times L. So you guys are going to finish this one. You're going to find L and then surface area. All right, let's go take a look at cones. The surface area of a cone, it says of a right cone, so it has to be sitting straight up, kind of like a sugar cone that we would see, is the sum of the area of the base and the product of pi and the radius of the base, that's a circle, and the slant height. So because we're talking about surface area and we're covering the outside, we're talking about this outside height, this slant height of the cone. So it's almost like when we look at the cone directly on from front to side, it almost looks like it's an edge of that. So for that slant height. So when we look at the formula, S is equal to the area of the base plus pi times radius times slant height. Or remember, the area of the base of a circle is pi times radius squared plus pi times radius times slant height. So let's take a look at some of these. I'm going to find the surface area of the cone. It says to the nearest whole number. You know we're going to the hundredths. So let's take a look. If you notice, we don't have L. We need to find the slant height. So we know the slant height is going to be the radius squared, which is 12, plus the height, which is 5 squared. So 12 squared plus 5 squared is 169. We've got to take the square root. All right. And so the square root of 169 is 13. So we have a slant height of 13. So now we're going to use what we know. It's pi times radius squared. So our radius was 12. So we're going to do pi times 12 squared plus pi times radius, which is 12, times the slant height that we found here of 13. Now they're going to have you combine some like terms. Remember we said we're just going to kind of type things into our calculator. So I'm going to do pi times 12 squared, which is 452.39, plus I'm going to do pi times 12 times 13, which is 490.09, and we're going to add those together. And so we get 452.39 plus 490.09. And we get approximately 942.48. So the surface area is about 942.48. We need to use our units. So this is feet squared. So you guys have a couple of checkpoints to do here. If we take a look at the first one, they give us the slant height. So we're going to fill in our formula. Our formula is pi times radius squared plus pi times radius times slant height times L. All right, so when we fill in what we know, we always have pi. The radius here is 10, so we're going to have pi times 10 squared plus pi times, the radius again is 10 squared, and my slant height is this 12 inches that we had, so times 12. Sorry guys, it's not going to be 10 squared, it's just going to be 10. So we're going to type in pi times Alright guys, I'm sorry about that, my computer shut off. Alright, let's take a look at pi times 10 squared is where we're at, which is 314.16, and then we're going to do pi times 10 times 12 for that pi times radius times slant height, which is 376.99. When we take 314.16 plus 376.99, we get 691.15, and we're going to use inches squared. You guys are going to do 5 and 6. You're going to do now, and then we're going to check in class. What you need to keep in mind is that for number 6, notice we don't have the slant height, so you need to get what L is equal to, and hopefully you figured out by now that the only way to do that is with the Pythagorean theorem. So you're going to do that first, and then substitute it into your formula. All right, we'll see you guys tomorrow.